What's up guys, this is Masi, welcome to my channel. In this video I want to talk about VSEPR theory, which stands for valence shell electron pair repulsion, and we define it as lone pairs, single bonds, multiple bonds that repel one another through repel forces. In this topic we focus on pairs of electrons in the valence electron shell of a central atom in a structure, and the preferred geometry of a molecule is the one in which the electron groups have the maximum separation possible. So that's why we will get 5 different basic electron group arrangements. So linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. So VSEPR theory, we have these 5 different shapes for a general type of molecules, which is ABX. A is the central atom surrounded by X atoms of B. So X is the integer, shows the number of B's, that it can change from 2 to 6. And the molecular formula alone is not sufficient to predict the shape of a molecule. I will talk about that later on, but based on the molecular formula we cannot really predict 100% what kind of shape we have. So let's start from 2 to 6. The first one is 2 electron groups, and we call it linear geometry. So it is usually in linear or bent form. That's why all of them are AX2. So some of them is in linear, some of them are in bent. So number of electron pairs 2, and linear shape we have, and type of electron pairs we have 2 bonding pair, and VSEPR notation is AX2, and the name of molecular shape is linear. For example, we have BEF2. Another group is 3 electron groups, which we call it trigonal planar. We have 2 different types of them. One we have lone pair, and the other one we don't have any lone pair. So both of them we have 3 electron groups, and the shape is trigonal planar. The first one, as you see here, we have 3 bonding pair, AX, AX, AX. And in the second one we have 2 bonding pair and 1 lone pair. So the first one is AX3 and the second one is AX2E. So the examples is going to be BF3, and the second one is SNCl2. Next one, 4 electron groups or tetrahedral. We have 3 different shapes. So the number of electron groups 4 for all of them, tetrahedral. And in one kind we have 4 bonding pair. The second one we have 3 bonding pair and 1 lone pair. And the third one we have 2 bonding pair and 2 lone pair. So it's going to be AX4, AX3E, and AX2E2. 2 lone pair and 2 bonding pair. 1 lone pair and 3 bonding pair, and here we have no lone pair and we have 4 bonding pairs. So we have tetrahedral, trigonal pyramidal, and we have angular when we have 2 lone pairs and we have 2 bonding pairs. So we have 3 different shapes for tetrahedral. The examples are CF4, PCl3, and H2S. Next group, we have 5 electron groups. So we have trigonal bipyramidal. So we have like 2 pyramids together attached to each other from the base. So we have 4 different types of shapes. Trigonal bipyramidal. So one of them we have 5 bonding pair, 4 bonding pair and 1 lone pair, 3 bonding pair and 2 lone pair, and 2 bonding pair and 3 lone pair. So AX5, AX4E, AX3E2, and AX2E3. So as you see here, the shapes, as you see here, linear T-shaped, seesaw, and trigonal bipyramidal when there is no lone pair. So AX5 such as SbCl5, and here we have seesaw when we have one lone pair, which is TeCl4 example, and this one, the third one, AX3E2, we have two lone pairs. The example is BrF3, and here we have three lone pairs and two bonding pairs. So we have linear system, but we have three lone pairs around it, which is XeF2. And finally, we have 6 electron groups. Octahedral. Octahedral, we have 3 different shapes. So based on the number of bonding pair and lone pair, we have 6 bonding pair, 5 bonding pair and 1 lone pair, and 4 bonding pair and 2 lone pair. AX6, AX5, E1, AX4, E2. So again, as you see here, we have octahedral. There is no lone pair. Example is SF6. And here we have BrF5. So we have the central atom here. We have 1 lone pair and we have 5 atoms surrounding this A. And the third one, we have 2 lone pairs, top and bottom, and we have 4 electrons around this central atom. So the example for this one is XeF4. So as you see here, we have these 5 basic different shapes based on the number of electron groups we have. We can have 2 electron groups, 3, 4, 5, and 6, and we have different shapes for each of them. I hope you enjoyed this video. Please leave me a comment if you have any question, and I'll get back to you as soon as possible. And please don't forget to subscribe this channel. Thank you.